Hello and welcome all on Unacademy JEE English. Yes, guys, Unacademy JEE English, a channel launched by Unacademy. Guys, on this channel, each and everything for IIT JEE will be taught you in pure English. And guys, today I'm going to take solid state lecture number 3. Yes, just a minute, guys. Let me check it. Am I audible? Am I audible, guys? Okay, please confirm. Hello, Roshan. Thank you for your wishes. Thank you. Thanks a lot. So, guys, first let me tell you today what. First of all, thanks for your compliments, guys. It's Teachers' Day today. Thank you again. Thank you very much. So, guys, today I will be taking hexagonal close packing. So, guys, it would not be just hexagonal close packing. What I'm saying is, it would be base centered, it would be CCP and hexagonal, but hexagonal will be one of the part. Prior to this, we have already covered unit cell, arrangement of constituent particles, everything we have already covered. So now I'm going to take lecture number 3. But before I start today's session, guys, let me tell you something about myself. Yes, guys, I'm Rahul Kaushik. I worked in Bansa classes quota. Since 2010 to 2020. Okay, so continuous 10 years I worked there, and during my tenure in quota, I mentored guys 2000 plus IITians and including many top rankers, and I was head of department in Bansa classes quota, guys. And now I'm here on Unacademy, India's largest and fastest growing online platform, to share all my experience and knowledge with you guys. Okay. Hi, Dr. Harshini Ashfa. Thank you. Thank you for your wishes, guys. Thank you. I hope you guys are enjoying this chapter. Yes. Okay, guys. So, guys, if you are planning to subscribe on Academy, guys, then I have very important piece of information. So first I will tell you how to subscribe. So guys, there are simple steps, and those steps are: step number 1, just go to Play Store or App Store, download Unacademy's learning app. Once you have downloaded it, installed it, and after installing, guys, you will be directed to these pages, guys. So you just have to click on the plus. Once you are clicking on the plus, you will be getting IIT JEE and NEET UG. So check the IIT JEE box, guys. And if you are checking the IIT JEE box, guys, now you have to hit the subscription button, right? And once you are hitting it, then you will be directed to a page. But before reaching that page, I am going to give you some important piece of information. Hi Krishna, thank you. That information is, guys, there is price hike that is coming. Yes, on September 10th. If you want to subscribe, guys, then this is the right time. Subscribe it before 10th of September, otherwise there is price hike. Okay, guys. Hello Hariharan. A big salute to you teaching on Teachers' Day. Thank you, Krishna. If I would have been with you in classroom, then there would have been some program, definitely. Hi Hariharan. Yes, guys, I hope I'm planning to teach you something special you will never forget, right? It's hexagonal close packing, and everything what I'm going to teach you today would be in 3D, although I'm talking to you remotely, but things would be 3D only. Hi Venkat Ramana. Yeah, Ramana, classes of 11th will be, we have scheduled Monday, Wednesday, Friday I take 11th class, and Tuesday, Thursday, Saturday. Hi Sarika. Tuesday, Thursday, Saturday I take 12th class. So we are doing redox reaction. Yes. Hi Venkat. Hi Sarika. Thank you, guys. Hello Priya. Namaste. Okay. So guys, now get your 11th standard subscription soon, because time is running out, and it's running out very fast, guys. Hi Harshu. Okay, thank you for your compliments, guys. These are the compliments which motivate us, right, guys? Okay, Harshu. Again, thank you very much, guys. I hope you guys are also enjoying this. Venkat Ramana, I'm chemistry teacher. Yes, I'm chemistry teacher, and we have covered mole concept, gases, state, periodic property, and quantum numbers. And right now we are doing redox reaction. Right? So guys, join it before 10th of September, and don't forget to apply this code Rahul Camp. This is my code, guys, and let me compare the old prices and new prices, guys. Right now for 1 year you have to pay 30,000, and if you are applying my code Rahul Camp you have to pay 27,000. Okay, for 2 year course you have to pay 36,000, and if you are applying my code you have to pay 32,000. Hello Vinay Sai. Yes, are you Vinay Sai or Pavan Sai? Yes, please confirm. So guys, in new structure, instead of 27,000, guys, you have to pay 34,000. You have to pay 34,000, and instead of 32,400, you have to pay 50,000. Yes, please tell me now. So guys, now we have 36,000, so increased fees is 56,000. So guys, don't delay. If you are planning, then okay, Hariharan. Yes, I saw you there as well. So now guys, now what is the current structure, guys? If you are going for 12-month subscription plan, then you just have to pay 2,500 rupees. And for 20, okay, you are, because there is one more student and his name is Pavan Sai. That is why I was asking. And for 24 months, you just have to pay 1,500 rupees per month, guys. And if you are applying my code, that is Rahul Kim, you will be getting 10% off. So on the plus, guys, on the plus, you will be getting structured course. After every class, there would be DPPs, there would be question bank, there would be sheets, periodic test, everything would be there, guys. So you will have access to not just my video lectures, but the video lecture and content of all the senior educators of physics, chemistry, and math. So guys, this is how you can subscribe to Unacademy. And now I'm moving ahead, guys. Now I'm moving ahead. Lecture number 3, hexagonal close packing. Okay, thank you guys. Again, thank you for your compliments. And now let's begin. Now let's begin, guys, today's class. Are you ready for it? Yes, tell me, guys, are you ready for it? Okay. So, guys, I was teaching you the solid state. Yes, I was teaching you the solid state, guys. So here in solids we have wolfenite, we have, I told you these are the solids. And how to identify solids, guys? Solids will have definite shape, they have definite size, they have definite volume, and all those things we have already covered. So you can easily identify the solids. So guys, first have a recap. In previous class, I was telling you how to create unit cell, how to create 3D unit cells. Yes, and you can create 3D unit cells using what? 2D square sheet. You can create them using 2D square sheet. Yes guys, any doubt? Yes, thank you Lokesh. So we created simple cubic, we created body centered, and then we were talking about face centered but could not complete the face center. So in simple cubic I told you that this simple cubic is formed by AA type layering, AA type layering of square sheets, right? And this BCC body centered is formed by AB type, AB type. Now face centered I will talk about it, right? So body centered, just before I start today's class, yes, give me the answer of some questions. What is coordination number of atom in simple cubic? Yes guys, tell me. What is the coordination number of atoms in simple cubic? Tell me guys, be fast. Anyone, is there anyone who can tell me this? So it is just for revision purpose. Venus, I know it is not 8. In simple cubic, no. Guys, it would be 6. It would be 6. So 8 is wrong. So Vinay, you have not revised yesterday's class. Yes, you have not revised it. You should revise it, Vinay. If you would have revised it, you would have answered me correct. So guys, the next question on your screen. Now tell me. I'm asking the basic problems on the topic which I covered in yesterday's class. So now what is coordination number of atom in body center? Yes, Vinay, I tell me. What is coordination number of atom in body centered cubic? Let's see who gives the right answer. Yes, guys. Yes, Lokesh, this time you are right. It would be 8. And how it would be 8? 4 plus 0 plus 4. So in its own layer, atom will not touch anything. It will touch 4 below and 4 above. Yes, Vinay, this time you are right. But Lokesh was fast. So guys, now tell me, what is packing efficiency of body centered cubic? Tell me. What is packing efficiency of body centered cubic? Yes, guys, tell me fast. You should remember this data actually. These are the data which are often asked in the exams. So I'm waiting for your answer, guys. Lokesh, this is not the correct answer. I'm asking it for body centered. 74 is correct for face centered. Yes. Is that done now? So guys, the packing efficiency, no Vinay, it would be 68%. Note it down. Yes, Parth, whatever I'm teaching you, that is sufficient for advance. You can find the notes. You will never find such content anywhere else. Yes, Lokesh. So guys, the next question, what is the packing efficiency of simple cubic? Yes, what is the packing efficiency of simple cubic? Yes, Vinay, you are right. Yes, Lokesh, very good. Yes. So for simple cubic, packing efficiency is 52%. Yes, Vinay, you are also right. Now I'm moving on to the next question. What is the relationship between E and R for simple cubic? Yes, tell me guys. For simple cubic, what is the relationship between E and R? Yesterday there was a problem in the JEE Mains. Yes, yesterday there was a problem on this concept. Thank you, Gadget Rana. Thank you. So guys, now do it. This was the problem in 2020 September JEE Main. JEE Main. Yes, Venus IA is equal to 2R. If you are making notes, then you would never stumble over such problems. And what about body center? What about body center, guys? Yes, tell me now. In body center, it would be root 3a is equal to 4r. Root 3a is equal to 4r. Yes, tell me now. What about face center? Tell me, guys. Yes, Sandeep Dan, you are right. So face center, no Vinay. Face center, you can say root 2a, it will be equal to 4a. Actually, these are the relationship. Yesterday I was discussing the JEE main exam and there was a problem over it. And if you don't know these relations, then you can't solve it. And yesterday I derived it. Yes, Sandeep Dan, you are wrong this time. Actually, I have not taught this concept. So you might have heard it anywhere else, right? Yes. So face center root 2a would be equal to 4a, right? Now you can do it, a would be equal to 2, whatever. So I generally remember this relation only. Yes, and then we can do this conversion. Okay, guys. So now, guys, let's move development of 3D lattice from 2D square sheet. No, it is not wrong. Wrong means I have not taught this. I intentionally asked this question because face centered I will be taking today only. So I just covered simple cubic and body centered in my previous class. So body centered I am revising, guys. Yes. Hi Matthews. Body centered I'm revising, guys. In body center what I'm going to do? Yes, I told you this is layer A and then we have layer B. So this arrangement will be called AB AB. This arrangement is called AB AB, right? So AB AB you can see, although I have discussed in previous class, but there are so many new students, so for them I'm telling you that if I take this sphere number 5, if I'm taking it, so guys, this 5 number is not touching any sphere in its own layer, but it is touching 1 2 3 and 4 layer. So in this case, guys, what will happen? These 4 spheres will not remain in contact. In layer, spheres will remain at some distance. So this 5 number is touching 1 2 3 4, and if this is layer A, this is layer B, so there would be again a layer A. So here I can show you A, this layer is B, and then this layer is again A. So here, guys, if you are connecting them, if you are connecting them, then it would be like this one, right? And you can again get it from here. Okay. So this 5 number is touching 8 spheres, 4 in the top layer, 4 in the layer below, and no. So I asked you the coordination number of atom, and because in crystal I told you what is crystal lattice, it is symmetrical uniform, it is symmetrical throughout. So all points would be identical. All points would be identical, right, guys? So now development of 3D lattice from 2D, and from here you can understand this layer is A and this layer is B and this layer is again A. So AB AB, if I cut it down, if I cut it down like this, then I will be getting it. I will be getting it. Okay, guys? Yes, tell me. Now, if I'm taking this R, R, R. So this is body diagonal, guys. So root 3a I write 4. So this is what I was revising, guys. If you have any doubt, please ask. Feel free to ask. Otherwise, I will be moving ahead now. And please make notes. If you are not making notes, you don't have copy and pen, you are wasting your time. So now, guys, I will move to the development of 3D lattice from 2D square sheet. That's important. And you people are not going to find it in NCERT. So be careful when I'm teaching it. So face center using 2D square sheet. So guys, suppose I'm making 2D square sheet here, right? Yes. This is a square sheet. and now you can get it done here. This is layer A, this is layer A, and now this is layer B. Yes. Okay, Vanessa, I will explain it, but later, because right now I'm teaching it. So we will see it later. Right now I can't take something in between. So yes, make these diagram by your hand. I will also show you the image of this. But if you are not making this diagram, then it would be difficult for you to understand it later when you will be revising it. Okay. So guys, here if I'm writing, this is one, right? So just focus on it, guys. Pink. Just focus on the pink spheres. This is 1, 2, 3, 4, and 5. Now we have 1, 2, 3, 4, 5, and this one is 6, this one is 7, this one is 8, this one is 9. Any doubt, guys? So actually what I'm trying to show you is, guys, here if you focus on the pink color, so there would be, let me make it now. Done. So if this is the cube, now let me show you the pink colors. Here I have 1, 2, 3, 4, 5. Yes, guys, this is the one. And now the sixth number. Sixth number is on the face of 2 and 3. 6. And then 3 and 4. We have 7. We have 8. We have 9. Right? And then again 2 dash, 3 dash, 4 dash, 5 dash, 1 dash. Yes. Note it down. And here you can see it. Yes. So guys, you can say if it is 3, it is 4. So in 3 and 4, on this face there is a sphere number 7, right? If I'm assuming it as 3, it has 4, so then this sphere would be 7. Let me change the color. 7, right? And if it is 3, 4, it is 5. So just check on the face of 4 and 5. It is 8. It would be 8, guys. Right? So 7 is on this face, 8 is on this face. So here you have 7 as well as 8. Any doubt, guys? Any doubt? So guys, this is face centered. Note it down. You can also make face centered. You can also make face centered using 2D square sheet. Hello Ravi Shiva Reddy. Hello. Yes. Now What is face centered cubic? Now I will discuss, guys. Yes, here it is formed by AB type layering of a square sheet, right? It is formed by AB type layering of square sheet. Next point, effective number of atoms per unit cell. But before that, uh, A is equal to B is equal to C, alpha is equal to beta is equal to gamma. Why? Because it is cubic. So if I talk about FCC, guys, if I talk about FCC, yes, just look at it. This is A, this is A. So guys, this length would be root 2A. It is R, it is R, it is R, it is R. So root 2A will be equal to 4R. Very important relationship. I just told you in the beginning of the class. Even IIT JEE has asked this relationship in the mains. Note it down. Right? So what will be the coordination number? Yes, guys, if you see this one number, it is touching 4 spheres in its layer and 4 green color and 4 will be below. So the coordination number of atoms would be 12. Coordination number of atoms would be 12. Good afternoon, Monica. And effective number of atoms? Yes, effective number of atoms. So in face center, there are atoms at the corners and then there are atoms at this. So there would be 4. Note it down, guys, everything. Coordination number is 12. This problem was asked in IIT JEE Advanced. Yes, coordination number in face centered. Right? So now I'm moving. Now I'm moving. Yes, guys. Can you tell me the density or packing efficiency? Yes. What is packing efficiency, guys? Tell me. So volume occupied, it would be Z into over equal. Volume occupied by molecule divided by total volume. Right? Yes, Savaris, what you are asking? I'm not getting your point. So it would be 4 into, and instead of A now you can write, now do it. Yes, and you will be getting 0.74. So guys, it is most efficiently packed. In this case, 74% of the space would be occupied. Right? Thank you, Ravi Shiva Reddy. Okay, tell me, guys. So guys, here I can show you where are the pink. If I make face center, guys, where is the face center here? Yes, you can check it here. Yes, this is the face center. Are you getting it? Are you getting it? Yes, tell me. So guys, where are the pink? From here you can see 1 and 2. This is 1, this is 2, and here we have 6. 2 and 3. This is 2, this is 3. Here we have 7 on this face. Then we have 3 and 4. So guys, this is 3, this is 4, and this 8 number. 4 and 1. So guys, this is 4, this is 1, and 9 number. So guys, these 4, yes, these blue colors, these are in the same plane, guys. and if these are in the same plane and these five, so I generally call this layer as A, B and A. So this layering style would be AB type, right? And if I turn this, if I rotate this like, yes, here you can see 1, 5 and 3. This is 1, 5 and 3. This is 3, 8 and 4 dash. So it would look like it. So guys, this layer would be, this is again example of face centered and we are rotating it. And here it would appear like 1, 2 and then 3. Let me show you it here. Just wait. Let me show you. Here it would appear like this: 1, 2, 3. So it would be 3, 5, 8, 194. 194, right? It would appear like hexagonal packing. It would appear like hexagonal packing. Yes, today when I will be discussing hexagonal, then I will take this as well. So here you can see it, guys. Again, this is root 2 is equal to 4r. So what is the nearest neighbor distance? Nearest neighbor distance. Yes, guys, can anybody tell me the nearest neighbor distance? Actually, this distance is called nearest neighbor distance. This distance. Yes, tell me. This distance is called nearest neighbor distance, and it is equal to r plus r 2r. So guys, it would be root 2a by 2. So a by root 2. So can you tell me the density? What will be the density of it? Face centered. Yes, guys, be fast. Can any of you tell me the density? Anyone? Anyone, guys? No one? So density would be Z into M over Na over Aq. What is this? M over Na, this is mass of one atom. These are number of atoms in one unit cell. So total mass in one unit cell, and this is total volume. So it would be Z into molar mass, Na into Aq, and Z would be 4. You have already calculated number of atoms. You have already calculated number of atoms per unit cell, and I hope now you got it. Yes, tell me, guys. You got it? So now I'm moving ahead. Any doubt, please ask. No doubt. So we have done everything about face center. We have done everything about face center. So the relationship for simple cubic is A is equal to 2r, and for body centered it is root 3a is equal to 4r, and for face centered it will be root 2a is equal to 4r. Yes, I hope now it is done. I hope now it is done. Tell me. Any doubt? Yes, guys. No doubt. So guys, now let's talk about development of 3D lattice now using 2D hexagonal sheet. So guys, prior to this I was talking development of 3D unit cell using 2D square sheet, and now I'm going to take 2D hexagonal sheet. So this case would be a bit complicated. Yes guys, this case would be a bit complicated, and now let's see how you people are going to solve it. right? So first of all, I have to tell you, what do you mean by close packing? So guys, is there anyone who can tell me the close packing? Yes. So close packing means when you are arranging the atoms, then it is a specific style of laying out of atoms in layers, assuming them to be rigid spheres, right? So this is called close packing. It is a specific style of laying out of atoms in layers, assuming them to be like rigid spheres. So this is called close packing. Now a layer is said to be a layer is said to be close packing if adjacent all layers are same or all are different. So guys, when you are arranging the atoms in layers, if all layers are same, then it will be called close packing. If all are different relative to each layer, then it will also be a close packing. So guys, now tell me, is it a close packing? Is it a close packing, guys? Yes, tell me fast. Just read the definition. It is specific style of laying out of atoms in layers, assuming them to be like rigid spheres. Just tell me now. Is AB AB? Yes, guys, this is close packing. Why? Because there are A atom on both sides of B, and every time it would be like this on. So every time, if there is symmetry, it means it is close packing. Now tell me, ABC ABC. Again, it is different. It is different. A and C both are in the voids of A B, because if it would have been above the B, it would have been A B B. So if there is symmetry AB AB ABC ABC, then it would be. Here we have same layers, and in this case we have ABC, then CAB. So this is not close packing. So in close packing, either all layers should be same or all should be different. Here all layers are same, and in these cases all are different. Here we have similar, so this is the issue. Here we have this one, so this is the issue, right? So guys, now we are moving on to the development of 3D lattice from 2D hexagonal sheet. Yes, now we are going to develop 3D lattice, and how it will be developed. So first of all, I'm going to take hexagonal close packing. So what I have to do is, guys, take a hexagonal 2D sheet in which around each sphere there are 6 voids. Now guys, actually it is easy to understand using these images, but guys, these images would not be helpful when you will be revising them. If you are making notes, then it would be better than that you make these spheres by hand. So just make it like it, right? And if you are making it like this way, if you are making it like this way, guys, this is called hexagonal layering. This is called hexagonal layering, right? And this one is 7. This one is 7. Okay. So if this is 7, you can get it. Now I'm showing you, this is 1, 2, 6. Now this is hexagonal because a hexagonal is formed. That's why it is called hexagonal layering, guys. Now it says we have 6 voids. Where are the 6 voids? Actually, voids have one more name, that is called interstitial space. This is second name of voids, interstitial space. Note it down, because later in this chapter I will be discussing interstitial compound, interstitial defect, everything I'm going to discuss. So just note it down, interstitial space. Okay. So interstitial space, now you know about it. So around each sphere it says 6 void. So this is one void. Okay, let me take highlighter. 1, 2, 3, 5, 6. I think you got the 6. Now if I'm taking one more layer of hexagonal sheet and placing that layer, guys, I'm going very slow because it is 3D. You have to visualize it. You have to visualize it. If I'm going to take one more hexagonal sheet and I'm placing it exactly over it, so what I will be getting, guys? So I will be getting AA type arrangement, but till today there has been no single compound which is found in AA type layering of hexagonal sheet. So there is no compound. So for hexagonal close packing, guys, what I have to do is I have to place the second layer in the voids of first, right? I have to take the second layer in the voids of first layer. I think now it is clear. Any doubt? Now it is clear. So now if another hexagonal sheet is taken out and put over the depressions of first layer, so guys, here I have placed it. So this is basically the first layer, and if I'm placing the second layer over it on the voids, here if I will be forming it, it would be too complicated. Yes, I hope you got it. Got it? Not got it. Are you getting it? So you can understand it from here. So if this is layer A, this is layer B, and we are putting the layer B exactly over the voids of A. So if I'm saying this is A, it would be B. So you can here observe that I'm placing the B over this. So this is AB type layering style. Why? Because I'm placing the second layer over the voids of first layer, right? And again the third layer. For third layer I have two options, guys. Either I can place it. Now we have two types of void. Now we have two types of void. Can you see those two types of void? Yes. Can you see two types? One is this. One is this, where I'm showing triangle. So this triangle you can observe, for this triangle it is 1, it is 2, it is 3, and this fourth one is actually it would be like you have these three and then you are placing the fourth, and over these three if you are placing the fourth, then in between these four this void will be there, and we call this void as tetrahedral void, and these tetrahedral voids are here. These tetrahedral voids are here, right? And what about octahedral, guys? So we have one more type of void here. Yes, these are surrounded by six spheres. There are three spheres like it, and there are three spheres like it. Six spheres. So this void is called octahedral. Yes. So when you are making AB type layering style, guys, you will be getting two types of void. One is called tetrahedral, and that tetrahedral is surrounded by four atoms. And one is called octahedral, and octahedral is surrounded by six atoms. Right? Tetrahedral is surrounded by four atoms, and octahedral is surrounded by six atoms. I hope now you are getting it. So this layering style is AB, and for the third layer we have now two options. And what are those options, guys? Now if I'm talking about the third layer, guys, so third layer I can place here. If I'm placing the third layer here, Then guys, you can easily observe that this is A, this is B, this would be C, because this third layer is neither over A nor over B. It is totally a different layer. So this arrangement is called ABC ABC layering. But no, if I place this third layer over this type of white, so guys, you can observe that this third is exactly above this pink first layer if I'm placing over this one. So this arrangement will be known as hexagonal or AB type arrangement. And using this arrangement, guys, here we have A, here we have B, and here again we have A. So this arrangement is called AB type. This arrangement is called AB type, and the unit cell obtained from this arrangement is called hexagonal close packing. Note it down. Hexagonal close packing, right? Hexagonal close packing. So now, development of 3D lattice from 2D lattice. So what is this? Now here you can see, guys, now I will show you it here. If I'm talking only about pink, just focus on the pink. No, it is not visible. Okay. Now first let me make 1, 4, 6, 7. So I will be using black pen here. Yes, I think you can see this hexagon, although this is not that much clear. Yes. So you can see there are 3 atoms, 1, 2, and 3 in between the 6 atom. So when I am making it, I can make it like this way. Because guys, once you see me how I'm making it, then it would be easy for you. And try to make it by your hands only. Yes. So you will be doing it like this way. Right? Yes. So seven days. And where are the 3 atoms? Those are at the center. Note it down, guys. This is the diagram. So this layer is called A, this layer is called B, and this is called A. So AB type layering, and unit cell form is called hexagonal close packing. Right? Unit cell formed is called hexagonal close packing, and in this case A is 2R, B is 2R, and C is different. So the calculation for C I will give you. Note it down, and once you have noted it down, guys, take a screenshot of it. You can note it down later on. Right? So guys, how it will look like? So this arrangement is called A, B and A. So AB, AB type, AB, AB type. Yes, now you can see them. These six are here. And then we have these three. And then again we have six atoms. So this is how it would look like, right? This is how it would look like. Any doubt? Yes, Vinay, are you guys getting it? Please tell me, are you guys getting it? Any doubt? So guys, just take a screenshot of it. I'm giving you some time. I'm giving you some time. Yes, be fast. Have you noted down? So I'm showing you. This is layer A, this is layer B, and this is again layer A. Yes, tell me. Yes. Yes, guys. Okay. Yes. So now I'm moving ahead, guys. I just told you that C A is equal to 2R, B is equal to 2R, and again it would be C. So just note this height, this C would be equal to, this C would be equal to 4 into root 2 by 3R. Now it is done, right? So when you know the C, guys, now I will do HCP is formed. Note it down, guys, very important points. Note it down. By AB layering of hexagonal sheet, right? And A is equal to B is equal to 2R, and alpha is equal to beta is equal to 90 degree, and gamma is equal to 120 degree. Why? Yes, here you can see it. This is 90, this is 90, and this angle is 120 degree. So alpha and beta are equal to 90, and gamma would be 120. Got it? So what is C? You have already calculated the C. C would be 4 into root 2 by 3R. C would be 4 into root 2 by 3R. Hi Amy, you are too late today. Yes. So calculate effective number of atoms per unit cell. Yes, what it would be? Thank you, Amy. Now just focus on it. We are doing very important thing, hexagonal close packing. There is a problem that is asked from this topic, and you don't have to waste your time. You can directly answer that problem if you are learning it. You are learning it, guys. So effective number of atom. So guys, here I can see one atom will be shared by 1, 2 and 3, and there would be 3 below. So one corner atom would be shared by 6 6 hexagonal unit cells. Here the unit cell is not cubical. Here the unit cell is hexagonal. So if these are shared by 6, so effective number of atoms per unit cell would be 1 by 6 into 12. Why 12? Because there are 12 items at the corner. 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 items at the corner. Then how many items at the face, guys? Yes, tell me. So it is 1, and then we have one more. So this is face center, this is face center. So I will write now, and there are 3 atoms, 1, 2 and 3, completely inside it. So you will be getting 6. So one unit cell will contain 6 atoms. Note it down, guys. One unit cell will contain 6 atoms. And now, what is coordination number of atoms? Yes, tell me. What is coordination number of atoms? Yes, guys, tell me. Vinay, this is helpful for IIT JEE. If you are learning it, then many a times direct problems are there, theory based, which you can directly answer. Right? Okay. So now you know about it. Coordination number of atoms, guys. Now tell me. If you take any number of atoms, suppose I am taking this atom, this A. So it is touching 6 atom in its own layer, and then when I will arrange another layer over it, it will again touch 3. So 6 in its own layer, 3 above and 3 below. So what will be the coordination number, guys? This problem was asked in IIT JEE Advanced 2 years back. 12. So 6 atom in its own layer, 3 above, 3 below. Right? 3 above and 3 below. I hope you got it, guys. So coordination number of atoms would be 12. And if coordination number is 12, then what would be the packing efficiency? What would be the packing efficiency? Tell me. 6 into 4 by 3 pi r cube. And now what is the volume of this? In case of cube, you guys could have done it a cube, but here it is not. Area of base into height. So height is equal to C. And what is area of base? So I generally tell you guys, like, if we connect these two, then I will be getting 6 what equilateral triangle. So guys, this is the base. The area of base would be root 3 by 4 a square into C. And now this a is equal to 2r. You know it. This a is equal to 2r, guys. Yes. 6 into 4 by 3 pi r cube over root 3 by 4. And what is C, guys? 4 into, yes, and you will be getting 0.74. So again, efficiency of hexagonal close packing will also be 0.74. Note it down. And please take snapshot of all these diagrams. Please take. These will help you. These diagrams will help you when you guys will be revising this chapter again. Okay. Yes, Vinay, Amy, are you guys noting it down? Note it down, guys. Yes. Be fast. I hope it is done now. Note it down, everyone. So guys, I told you in hexagonal close packing and FCC, yes, there were two types of void. Here you can see, and this triangular void, these are called tetrahedral void and these are called octahedral voids, right? So tetrahedral void, it is surrounded by 4 atoms, and octahedral void, it is surrounded by 6 atoms. So we have two types of void, tetrahedral and octahedral, right? So anytime or every time whenever you will be doing this layering style, tetrahedral as well as octahedral, both types of void will be formed. So guys, I have one relationship between them, and that relationship is if there are n atoms per unit cell, then there will be 2n tetrahedral void and n octahedral void. Hi Hemalata. So in HCP we have 6 atoms, so there would be, hi Hemalata, there would be 12 tetrahedral voids and 6 octahedral voids. In FCC, hi, I have seen your hi. Now focus on your studies, Hemalata. Yes. So now in FCC there are 4 atoms and there would be 8 tetrahedral voids and there would be 4 octahedral voids. Right? Happy Teachers Day. Thank you. Thank you, Hemalata. Now note it down. And don't use this formula everywhere. It is not applicable for simple cubic or body center, because in simple cubic, cubical void is formed. In simple cubic, cubical void is formed. That's why I am saying it is applicable only for hexagonal close packing and face centered cubic. Right? So note it down. If there are 4 atoms per unit cell, then there will be 8 octahedral voids and 8 tetrahedral voids and 4 octahedral voids. And in HCP we have 6 atoms. We have just done that calculation. So guys, what about density? So this was packing efficiency. Density would be 6 into C, right? Any doubt? Please tell me. Any doubt, guys? Please tell me. So now you can calculate the density, you can calculate the efficiency, you know the coordination number for hexagonal, you know how hexagonal is formed. It is formed by AB type layering. It is formed by AB type layering. And now you know if there are n atoms, then there would be what? 2n tetrahedral voids and n octahedral voids. Yes, guys. Tell me if you have any doubt, please ask. Any doubt? Right? So now I'm moving ahead, guys. Now development of 3D lattice from 2D, and I'm going to make face centered cubic. So guys, if you remember, today when I started today's class, I told you that face centered can be formed. Face centered can be formed by what? Square sheet as well as hexagonal sheet. So how we can create the face center using square sheet? I just told you we can create the face center using square sheet in the beginning of the class. Now I'm going to create the same face centered, and the another name for face centered is CCP. CCP means cubic close packing. CCP. So CCP and FCC are same. There is no difference between them. Everything is same. These are basically synonyms, two names, right? So when it will be formed? When ABC ABC type layering is done. So what is ABC ABC type layering, guys? Now here you can see this is layer A, this is layer B, and this is C. This C is neither above A nor above B. It is totally a different layer. But here if I'm saying this is A, this is B, and this is again A. So this A would be over the first layer. This third layer, first, second, and third. This third layer would be exactly above the first layer, right? And here this is the third layer. It is not either first layer or second layer. It is totally a different layer. So how we are going to make it? How we are going to make it, guys, from hexagonal sheet? Now you can observe it like we have one here. This is layer A, B, C, and again A. So it is formed by ABC, ABC. So guys, if somebody asks you to make CCP, what type of layering style is used? Yes. Okay, Norman, I will discuss your issue as well. So in ABC, ABC, guys, I will be using, this is used to form FCC using hexagonal sheet, right? You can also make FCC using ABAB type layering, but in that case, you have to take square packing, right? Yes, Norman Javed, weak, if you have weak inorganic, then it would be better to go for NCRT, right? Okay. So now tell me, guys, this is layer A, this is layer B, this is layer C. So again, you can see these are hexagonal layers. Like this happens only in hexagonal, because in square packing is like this way. So this is hexagonal layer like. So guys, when I tilt it, just to show you, when you tilt it and you merge all these three layers, when they come close to each other, this is what I have shown you. When they will come to each other, it would look like it. So this is again layer A, B, C, and A. And in the cube, it will look like it. We generally make it. So FCC, you should remember, FCC can be created. FCC can be created using ABC ABC type layering, right, guys? FCC can be created, and there are two ways to create FCC. This problem was asked in IIT JEE. Right? You can even tilt it along this axis. If you do it vertically, then this yellow would be shown here, right? And let me make one more thing, and be careful about this. This is the triangular. Yes, these three are in one plane, and these three are in another plane, right? Their planes are different, right? Any doubt? Any doubt? Any doubt, guys? So now we have FCC using hexagonal sheet. So everything would be same. Here you can see, again I have shown you, this is the problem IIT JEE asked. So this is A, B, C, and A, B, C, and A, right? So these are the layers, guys. This is one hexagonal layer, this is one hexagonal layer, this is another hexagonal layer. So it would be like one is like this way and another is like this way, and two layers would be separated by some distance. They will be touching, but one layer, two layer, and then we have. So guys, you can take a screenshot of it. That's very important. Just take a screenshot of it. Okay guys, any doubt? So guys, now I'm moving to the types of void, right? I'm also I'm also trying to do, or we will try to complete it. So what are voids, guys? Now if you have any doubt, any query, please ask guys. Whatever we have done till today, that was very important, and most of the things were in 3D. So guys, I'm giving you 2 minutes. Please ask if you have any doubt, any query. So again, what fight is going on here between Devdutt and Hemlata? Okay guys, just focus on your studies. Focus on your studies. Yes. Do you have any query? Yes, no man, Hemalata. Tell me. Vinay Sai, Sandeep Dan, anyone. So do you guys have any query you want to ask anything guys? Feel free. Otherwise I'm moving ahead now. Otherwise I'm moving ahead now. Yes, tell me. Okay, don't fight guys now. So guys, now I'm going to start voids. So can you tell me what are voids? Yes guys. So what are voids? Voids means blank space or free space. So when I'm talking about trigonal void, how it would look like? 1, 2 and 3. So guys, it is like you are arranging footballs. Okay. It is like you are arranging footballs in your room. You have suppose 50 footballs. So now tell me, if you are using football, then between those football there would be space like it, right? And if there is a space between them, then what would happen guys? You can place one more football. So three football are like it, and you are placing the fourth one. So when you are taking three and fourth one is above them, guys, what would happen? This is these are three and this one is fourth. When you are doing it in between four atoms, there is a space or there is a void, right? That space or void, that space or void, like this one. This is tetrahedral void actually. This is tetrahedral. So when I'm talking about trigonal, I will talk only about 2D. So if you have placed three coins in 2D, just think like it. If you have placed three coins, so fourth coin would touch between them. So normally I will show it like capital R. So between the footballs, there can be cricket ball, and cricket ball can be accommodated in the void, right guys? So this is cricket ball. So the size of cricket ball is smaller than the football. So once you are connecting it, so this angle would be 30 degree. This is R plus R. This is R plus R. So now you can do this calculation easily. And the thing, yes, this one is called void, and radius of void is small r. So cos 30, yes, tell me the value of cos 30. It would be, right? So it would be, Yes, note it down, guys. So if you are going to calculate it, you will be getting, so R upon R will be, so you can say if football radius is 100, then you can accommodate a cricket ball of 15 centimeter radius. So only 15%. Yes. And this is called triangular wide. This is called triangular wide, guys. Note it down. This is called triangular wide. Any doubt, guys? No doubt. So if somebody asks you what is the coordination number of triangular wide, tell me what is the coordination number of triangular wide. So I would say coordination number of void is 3, and this is the radius relation, right? So guys, this is all for today, and in the next class I will be taking tetrahedral void. Today it cannot be covered because it is time consuming, and after this I will take octahedral void. Then I will also take cubical void, how these octahedral and cubical voids are formed, and what is cubic void, right guys? So next time I'm going to take all these voids, and after this we will take the location of voids. Actually, where exactly the voids are present in face center? Where are the tetrahedral voids? Where are the octahedral voids? Exactly at what place they are present, right? So I have to tell you that thing as well. So number of tetrahedral void in FCC, number of octahedral void in FCC, then we will calculate the shortest distance between tetrahedral voids and octahedral voids, right? In HCP or CCP, if there are n atoms, then there will be n octahedral void and 2n tetrahedral void. So guys, in the next class we are going to do it, and in HCP and CCP this thing I have already told you. Then I will discuss about ionic compounds. What are ionic compounds and what are their constituents, what make them, right? So next class will be on Tuesday, Bhanupriya. Next class will be on Tuesday, right? So there are many things: coordination number of cation, anion, then this stable bonding configuration. After this I will be taking rock salt, and then we will be taking cesium chloride. So these ionic crystals. Okay guys. So guys, if you really like today's lecture, then don't forget to share it and like it. Everyone, please like it and click on the bell icon so that guys you can get latest notifications. Click on the bell icon. So guys, here if I'm moving how you can subscribe to Unacademy, I have to tell you those simple steps, guys. And those simple steps are, just go to Play Store or App Store, download Unacademy's learning app. Once you download it, install it, and after installing, you will be directed onto this page. Once you are on this page, then click on the plus, and then two options will be populated. You have to check IIT JEE, and once you check this box, hit the subscription button, guys. And once you are hitting the subscription button, you will be getting these options. No, you will not be getting these options. Guys, this is information which I'm giving you. If you guys are planning to subscribe Unacademy, then guys, don't delay. Do it fast, because after 10th September there is a price hike. So before 10th September, if you are going to do it, it would be beneficial for you. Yes. And if you are applying my code, Rahul Cam, then you will be getting flat 10% off, right? But do it before 10th of September, right? And let me compare the prices as well. So just don't talk about these were now gone. So guys, if you are going for 1 year program right now, you have to pay 30,000, and on applying my code you just have to pay 27,000. But after the price hike, instead of 27,000, even after applying my code, guys, you have to pay. Sir, day by day, sir, classes. Yes, Bhanupriya, what are you saying? Can you explain me? So guys, instead of 27,000, you have to pay 34,000. And instead of 32,000 for 2-year program, which currently you have to pay, if you are applying my code, you have to pay 50,000. It's a huge gap. And if you are planning to subscribe Unacademy, guys, then this is the right time. Right? Then this is the right time, guys. You can do it. Okay. So guys, don't delay now. And currently, if you are subscribing it for 12 months, you just have to pay 2,500 rupees per month. And for 24 months, you just have to pay 1,500 rupees per month. Okay. And if you are paying 2,500 rupees per month, you will be getting access to not just my video lectures, but the video lectures and content of all the educators. Right, guys? And not just their content, guys. Every fourth class would be doubt clearing session. Every fourth class, it would be doubt clearing session, guys. Then you will be having live quizzes. Yes, there would be live quizzes, guys. And after live quizzes, guys, there would be mega quiz after each topic. And let me tell you the most important thing, guys. Your course would be purely structured. After every class, we are going to provide you DPPs and modules. And there would be regular tests. And regular tests are very important to assess your performance. Okay, guys. And don't forget to use my code, that is Rahul Camp. By using this code, you will be getting flat 10%. Right, guys? So this is all for today, guys. So now take care of you guys. I will meet you again. I will meet you again, guys, day after tomorrow. Tomorrow we have a special session. So guys, let's meet tomorrow and take care of you guys.